In this lesson, we're going to look at simplifying, multiplying, and dividing rational expressions. So just to give you a little background of rational expressions or how and when we might encounter a rational expression, we can look at this little word problem right here. Mr. Smith's science class is taking a trip to the zoo. The bus costs $500 for the day, so that's an amount that the group has to pay. And tickets are $12 for each person. So if you're trying to calculate the total cost of this trip for P amount of students, you could write an expression for this where you know you have to pay the $500 for the bus, and added on to that, it's $12 per person. So the expression for that would look like 500 plus 12p. That would be set equal to the total cost. Now, this is not a rational expression. However, if we then wanted to calculate the price per, or the cost per person individually for this entire trip, then each person's got to pay their fair share to go on the trip, meaning that we could divide this entire expression that represents the total cost for the trip by the number of people, or by each person going on the trip. And this would calculate how much each individual person would have to pay. This right here is an example of a rational expression. So a rational expression is an algebraic fraction whose numerator and denominator are polynomials. Remember, polynomials are expressions made up of one or more monomials. So for example, 450 plus 4n over n is a rational expression. 7x plus 3 over x squared minus 9 is another rational expression. Your numerator is a polynomial. Your denominator is a polynomial. So today we're going to look at the basics of simplifying, multiplying, and dividing these kinds of expressions. Okay, before we get too far into our simplifying practices, we do need to think about, since we're dealing with division, what number we can never divide by. And it's important to remember that you can never divide by 0. I always say, remember that we are mathematicians, not magicians. We can't take something like 5 pieces of pizza and divide it into no parts and make them go away. This is not possible. It's undefined. So, with that being said, when we are simplifying rational expressions, we do need to keep in mind that our denominator can never be equal to 0. So what you'll notice is our denominators will have variables in them. That's what makes them sometimes monomials and polynomials. And so whatever the value of that variable is, we will have to state that it cannot be equal to 0. So to do this, we will state any possible values that the variable cannot be equal to, and we will call these excluded values. For example, if we had 450 plus 4n divided by n, we could simplify this if possible, but we would have to, with our answer, state that n can be anything, but it cannot be equal to 0, because that would make this denominator 0, which is not possible. So the process for simplifying rational expressions is to start by factoring the monomials or polynomials in the numerator and denominator. Once we have done that, we will state any excluded values that would make that denominator 0, because the denominator cannot equal 0. After we do this, we will then cancel any like terms we see, and the factors that are left will make our simplified rational expression. So here is an example of a rational expression. I've got a trinomial on top, a trinomial on bottom. So step 1 is to start by factoring the monomials or polynomials. So to do this, you may want to, off to the side, carry this numerator and denominator over and work these out separately. So let's see. On this problem, oops, this is supposed to be a 1. We want factors of negative 21 that add up to be our middle term of 4. So for them to add up to be a positive 4, we would need, let's see, factors of 21 are 7 and 3. So the 3 would have to be negative, the 7 would have to be positive. So that would factor to an x minus 3, x plus 7. For the denominator over here, to factor that, we want factors of positive 21 that add up to be negative 10. So factors that would add up to be negative 10 would be negative 7 and negative 3. So here we've got x minus 7, x minus 3. Once we've done that, we're going to rewrite our fraction with those factored out expressions now in the place of where our trinomial started out. From here, before we cancel any like terms, we are going to state our excluded values. Whatever the denominator simplifies to be, we cannot have it simplify to equal 0. Therefore, because this is multiplication, if x minus 7 were to simplify to be 0, that would be 0 times a number, making the denominator 0, which would not be good. And in the reverse of that is that if x minus 3 simplified to be 0, then this term would be 0 times x minus 7, whatever that may be, and the whole thing would be 0 again. So to state our excluded values, what we will do is take each factor individually and set each factor equal to 0. And really what we're doing here, x minus 3 equals 0, is solving for what actually would make those parts equal 0. And so this, oops, okay, oh my goodness. This would make it, disregard that, 7 for the x. Here, if I add 3 to both sides, then x equals 3. So what we find is that if x were to equal 7 or 3, both of these scenarios would make the denominator equal 0. So actually, x cannot equal these values. If I were to put 7 in for my x's, this is 7 minus 7, which is 0 times, and 7 minus 3 is 4. Well, it really doesn't matter what that is. 0 times 4 is 0. And I can do the same with the 3. 3 minus 3 is 0. 3 minus 7, negative 4. 0 times negative 4 is still 0. So these are both excluded values. Okay, at this point, we've factored, we've determined what values our denominator or our x cannot be equal to. That would make the denominator 0. Next, what we're going to do is cancel out any like terms that we notice. So the reason that we'll do this is because whatever x is, x minus 3 up top is going to be the same value as x minus 3 on bottom. So here I've got something divided by itself. Anything divided by itself is 1. So this number divided by itself is going to cancel out to become a 1, meaning that we've got our numerator times 1, our denominator times 1. Now x plus 7 and x minus 7 will not cancel because they have different signs. So if x were 5, for example, the numerator would be 12, the denominator would be negative 2. You can see those are not the same expression. So those x plus 7, x minus 7 would stay. And so our simplified rational expression is x plus 7 divided by x minus 7 as long as x is not equal to positive 7 or positive 3. And this entire expression with the excluded values is how you'll state your final simplified answer. So here's our next example. We've got a trinomial up top, a trinomial down below. Step 1 is to factor the monomials and polynomials. Whoops, didn't mean to show that. Notice that your numerator has a GCF. So let's pull that 3 out of the whole thing. And remember, with our factoring methods, we don't just stop after GCF, we keep going. So now I have a trinomial without a coefficient. I need factors of negative 4 that add up to our middle term of positive 3. So that's going to look like a negative 1 plus 4 so that it becomes a positive 3. So that should look like your numerator factored. And then the denominator should factor as well. Now your denominator is a trinomial with a coefficient. So remember, you need to multiply 3 times negative 1 to get negative 3. And we need factors of negative 3 that add up to be the middle term's coefficient of negative 2. So in this case, we will need the 3 to be negative, the 1 to be positive. Once you do that, and I'm going to come over here so I have more room, we rewrite our trinomial, oops, with the middle term as negative 3x plus 1x minus 1, so that now we can finish the factoring by grouping. So x minus 1, pull something out of the second one to make your terms as 3x plus 1 times x minus 1. And that's what our denominator factors to. Before you go canceling, I know you see those x minus 1s are the same and you want to cancel them out. Before you do that, you need to first state what values x cannot be equal to that would make the denominator equal to 0. So we'll take 3x plus 1, and hopefully you can start to be doing this in your head, but set it equal to 0. You subtract 1 from both sides, and then divide by the 3 that's left. Running out of space, but x would equal negative 1/3 in that situation. Then the second term set equal to 0, add 1 to both sides, x would equal 1. So the terms that x actually cannot be equal to are negative 1/3 and positive 1. Those are excluded values. Now that we've done this, we can cancel the x minus 1 factors that are the same because they would divide out to be 0. And then just recopy what's left and state the excluded values there with it. You do not have to re-multiply out this numerator. It's fine to leave it as is, fully factored. All right, here's your next example. I'll let you try this one on your own, and when you're ready to check it, pause the video, then click play to check. Okay, so hopefully you recognize the numerator was a difference of squares and the denominator had a GCF of r minus 6, meaning that your factors, 2 does not equal 0, so we don't need to worry about that factor. R minus 6 means r can actually not equal positive 6. So once you cancel the r minus 6's, you are left with r plus 6 over 2, as long as r does not equal 6. All right, and that takes us to the end of simplifying rational expressions. Next, this leads us to multiplying and dividing rational expressions. Just to make a note here, we are not going to continue stating excluded values for these. However, you should know that to find them, you set your denominator's factors equal to 0. But I'm only going to make you state the excluded values for simplifying expressions. It's just going to be a lot for us to do with each one of these kinds of problems. But just do keep in mind, your denominators never should equal 0 if you did, in fact, solve for your variables. To multiply and divide rational expressions, you'll find the steps very similar to simplifying, where you're going to factor and or keep, change, flip. That's what KCF stands for. And this is used when you are dividing rational expressions. You will then multiply and cancel or cross cancel, and whatever's left that did not cancel out with anything makes your final answer. Okay, so let's start basic. Here we are multiplying two rational expressions made up of monomials up top and bottom. Step 1 would be to factor. That's already done for us. Step 2 would be to then multiply across and cancel or cross cancel. So what this could look like is I could cross cancel my 6 with my 3 here to cross simplify. So they both have a factor of 3. So that leaves me with a 2 up there and a 1 here. And then top times top is 4, and bottom times bottom would be 3x squared. You could also just start by multiplying straight across to get 12 over 9x squared. Then you would just need to simplify the 12/9 to 4/3. So regardless of how you choose to simplify at that multiplying step, we should all arrive at 4 over 3x squared. Next, here we've got rational expressions made up of polynomials. So here is where that first step of factoring is going to come into effect. So this is really 4, well, in this case 3, but factoring problems in one. You have to factor this numerator, which means in this case there is a GCF. You have to factor this denominator, another GCF, but this time the GCF is 5x, and you're left with x plus 3. And this is a difference of squares, so that breaks down to x plus 2, x minus 2. So you have to do all of that factoring. Take the time to rewrite this entire problem with all the factored out pieces. Once you have done that, this is where canceling and cross-canceling comes into play. So I see the x plus 2 and the x plus 2 binomials. Those will divide out. They will cross-cancel and simplify there. Next, I'm going to look to these monomials. There are no more binomials that would cancel with either of these. So looking at my monomials, 6x squared could cross-cancel with a 5x, in that here is 1x, and there's 1x there that will cancel, making that now an x to the first. We also have here, to simplify, 5 divided by 5 is 1. So you can see a lot of canceling, cross-canceling going on to reduce. Like I said, you could multiply across from the beginning to do this and just kind of bring everything together. And this may help you see what can simplify more easily if you're not seeing the cross canceling. And here you can see vertically, okay, 30 over 5 is 6 over 1, and then 2x is 1x, leaves me with 1 up there, none in the bottom. Regardless of how you do that, oh, I already did all the canceling, we're left with a 6x up top, an x plus 3, and an x minus 2 on the bottom. And that's our final answer. Note that if you did state excluded values, you would do it at this step before canceling. So just so you know, x should not equal 0, x should not equal -3, x should not equal 2 or -2. All of those values for x would be excluded. So you would see there would be quite a list there. All right, here's an example with division. So we've got a fraction divided by another fraction. So to divide fractions, we copy or keep, change, flip. And so we copy the first fraction as is, change division or multiplication, and flip or write the reciprocal of our second fraction, x plus 1 over 5 now. Once we've done that, there is actually no factoring to be done. We can't factor anything, but we can begin our cross-canceling. X plus 1 times x plus 1, or we'll divide out by this x plus 1 across. If you need to put parentheses or round terms with plus and minus to remind yourself those are locked together, please do that so you can see they are the same factor. And we're left with 4/5. Here is another example of a division problem. So every time you see dividing rationals, I want you to take that division and recopy everything, changing this division to multiplication and writing the reciprocal of your second fraction, flipping it. Do not do this until you, do not factor until you have done this step. Only once you have copy, changed, flipped, or keep change flip should you then go ahead and factor. So from here you need to factor numerator, denominator, numerator, denominator. And from there we will cancel and cross cancel. I'll give you a moment to go ahead and factor, so click pause to factor and then click play when you're ready to come back together. Okay, you have now factored. Hopefully you notice the numerator was a difference of squares. Here a trinomial without a coefficient, trinomial that had a GCF, then trinomial without a coefficient, and a GCF on the bottom. So here we get to now cancel out lots of factors. And the 4 divided by 2 leaves us with a 2. And I believe that's it. And that's our final simplified answer. There are some extra practice problems if you have time. You can scroll through, click play when you're, click pause to practice, then click play to check. And we'll just finish out this lesson here where you're practicing factoring and canceling on your own. Okay, so this one should simplify like that, and those 3's cancel. So that's how we're left with a 5 halves. Okay, go ahead and work this one out. All right, you can stretch out this c plus d squared. Then you can see that one of those sets cancels. You've got a c here that cancels with two of them up there, or one of them up there, leaving two up top. The 6 and the 4 will reduce, leaving us with that expression. Okay, go ahead, work it out. All right, we'll factor and cancel. All right, and that is the end of that lesson.